My name is Mark Grand. I'm going to be telling you about some best practices for error handling in Java. When your code detects an error condition, it should do something to cause different behavior than when there are no errors. Usually, the best way to do this is to throw an exception. The highlighted code on the screen is an example of throwing an exception. When you throw an exception to handle an error, there should be a message in the exception that describes the error. If the error involves a value that might be helpful to someone to understand the error, then the value should be included in the message. In this case, we're concatenating the error onto the end of the message. Java comes with many predefined exceptions, such as null pointer exception and IO exception. These exception classes are useful for catching specific conditions that are detected by the Java runtime library. To report errors detected by your own application's logic, the application should define its own exceptions related to what the application is doing, not how features are implemented. For this reason, the application we are looking at defines an exception called Resource Not Found exception. It is thrown when the application is unable to find a data resource it expects to read data from. The exceptions defined by an application could all be defined by a subclass of a predefined exception, such as runtime exception. However, it is better to have one exception in the application that is the superclass of the others. In this case, we have defined an exception named application exception. Application exception is declared as a subclass of runtime exception. This means that methods that throw these exceptions don't need to declare them in a throws clause at the beginning of the method. It is very helpful to document in Java comments what exceptions a method throws. Looking through this method, it is easy to find that it throws an unchecked IO exception. But it is also easy to miss the fact that it calls another method that throws a resource not found exception. Documenting the thrown exceptions makes it easy for programmers to know what exceptions to expect. It is common for methods of one class to call methods of another class to call methods of another class, and so on. When a method detects an error condition and throws an exception, it puts a message in that exception that reflects the point of view of the method that threw it and the concerns of the enclosing class. For example, this call to read here may throw an IO exception with the message unexpected end of file. Now, the concerns of this read data as string are a little bit different, and so it catches the IO exception that may be thrown out of read and provides in its place a new exception with the message error reading data resource, its point of view. It also passes into the constructor the original exception. This is important. By doing that, the original exception is chained to the new exception. When the new exception is caught and that code logs the exception, the logging mechanism will first include in the log item the message and stack trace from the unchecked IO exception, and then it will include the IO exception from read. Having this chain of exceptions in the log can be very helpful in diagnosing problems. Logging is an important part of error handling. It is the mechanism by which we learn that exceptions have happened, why they happened, and from where they were thrown. There are two different flavors of logging. One is for informational messages like this, where we're trying to report the successful completion of an operation and some values that are related to the operation. And to do that, we have a message, and that includes a placeholder right there. And logging that way with the placeholders and any values you want to merge into the message is the recommended way to do this. Now, when we log for error reporting, we need to do it a little bit differently. We have a logging call that has no placeholders in its message, and the exception is passed in, but those are the only two parameters. So we always pass in exactly two parameters to this. I've seen some unfortunate ways of logging that try to use the informational style for error reporting, and that has some bad results. So if you do it like this, where you have a call to the exceptions get message, you log the exception and its message, but you lose the stack trace, and you lose the chain of underlying exceptions. So all of your diagnostic information is left out of the log. Slightly better is this version of it, where you capture the message and the stack trace from the exception, but you lose the chain of underlying exceptions. When you are logging for errors, always do it this way, with no placeholders and just the exception as the second argument. To sum up, I have told you 5 things you should do to have good error handling in Java applications. Use exceptions to report errors. Application logic should throw application-defined exceptions. One application-defined exception should be the superclass of all others. Document the exceptions a method throws. Log exceptions as exceptions, not as informational messages. Hope you found this helpful.